Do all of our votes have the same value? In the recently released EBRC white paper, we see that one of their main focuses was maintaining the number of electors per MP. This is very important in a democracy to ensure that everybody's voice is equally heard, even with population changes and shifts in the country. And here they've reported that with the new 2025 proposed electoral boundaries, they've managed to maintain about 28,384 electors per MP. If you made it through Sec 3 math, you should know that statistics is not just about averages or means. Paying attention to other factors like the broader distribution could also tell us more about how each individual district performs relative to this average. So as you can see in the histogram plotted here, we have all of these different districts and how many of them correspond to a certain number of voters per MP. So the average we've identified here is exactly the same as the one reported in the EBRC report. But at first glance, we can already tell that this is not a very even distribution. It's bimodal, with neither of the modes corresponding to the mean. So you can see that while this average of 28,000 voters per MP is maintained, actually not that many districts match this value closely. And if you pay attention to the range on the x-axis, you can see that we range from 22,000 all the way to over 33,000 voters per MP. So what does this mean? So if you are in one of these districts here with fewer voters per MP, that means there's fewer of you sharing that MP and your voice will be heard more. On the other side of the spectrum, if there's almost 33,000 of you sharing one MP, it is less likely that your individual voice is going to be heard or represented. And this is the reason why we are and should be so focused on this voter-MP ratio. For this election, if you're from Kebun Baru, Marymount, or Mountbatten, lucky you. On the other hand, if you're from West Coast Jurong, Ang Mo Kio, or Bukit Panjang, it might feel a little bit crowded. If you're also interested, we have the standard deviations computed and they're around 3,000. But what's most striking to me personally was looking at the district with the most number of voters per MP and the district with the least number of voters per MP. So Bukit Panjang and Kebun Baru. I mean, I'm no mathematician, but 33,000 and 22,000, I think that's a 51% difference. For a committee whose main job is to maintain the average ratio of electors to elected MPs, I think we can expect a little bit better of them. Let's look at another extreme case, which is the 5 MP GRC with the fewest number of voters, Marine Parade Braddell Heights, and the 4 MP GRC with the greatest number of voters, which is Sengkang. Marine Parade Braddell Heights has 131,000 voters and Sengkang has 126,000. So with a mere difference of 500 voters, this is translated to a full 1 extra MP in Parliament. In fact, if we took the number of voters in Marine Parade Braddell Heights GRC and gave them 4 MPs instead, the ratio of voters to elected MPs would still be within this range, at around 32,800, so on the upper end. Similarly, for Sengkang, if we took the same number of voters and gave them 5 MPs instead, it would still fall within this accepted range here at around 25,000. So what we should really expect from this distribution is something that is narrower so that it is unambiguous how many MPs you're going to assign to a district with a certain voter size. Like in the example I gave, the 2 districts, Sengkang and Marine Parade Braddell Heights, could very reasonably have either 4 or 5 MPs. Having such a big range allows the ambiguity between 4 or 5 MPs to exist and does make the decision of 4 or 5 quite arbitrary. I mean, of course, due to urban planning, the shapes of our actual residential districts, we can't expect all the districts to be exactly at this mean of 28,000. So ideally, the distribution we want to aim for is to have a greater concentration of districts around this mean and then a smaller concentration of districts along the 2 sides. A shape like this is called a Gaussian, but given that a chief statistician is on the EBRC board, I think you guys should know this already.